I have already finished the threader box and the power unit, and it is time to make two shafts together to transmit the power. Hi, welcome to Slow Engineering. I'm David. In the previous video about the preparation stage, I suggest 3 power transmitting methods: direct coupling, connection between 2 spur gears, or using a chain mechanism to connect 2 shafts. Now, let me share my experiments in selecting the most suitable solution. On my first attempt, I tried to replace the coupling, which extends the total length along the axial direction. So the first approach is trying the spur gears. While researching spur gears, I discovered that they are not a suitable solutions due to their size, weight, and noise issues. Firstly, I need to find a size that matches the width of the shredder box and ensures that the gearbox output shaft is aligned in a 1-to-1 gear ratio position. If the gear ratio exceeds 1, another reducer changes torque and speed, leading to additional power efficiency issues. Secondly, heavy-duty spur gears would add extra weight. Even with proper lubrication, it could still produce noise. After the initial approach failed, I decided to try the chain mechanism. The chain mechanism consists of 2 sprockets on each shaft. A chain hooks up 2 sprockets to transmit power, unlike a belt mechanism that separates tension. The chain only has one side in tension, which means it transmits all the force. It would be better to check the chain's limit to avoid any breakage. Gather pitch circles based on the different size of the sprockets. Then you can calculate the loaded tension on the chain using the input pitch circle radius with the generated torque by the gearbox. Let's say you already have the torque value from the gearbox output shaft. As I calculated in the previous video, the torque is around 441 Nm. To get the force or so-called tension, you need to divide the torque by the pitch circle radius of the input sprocket. It's important to note that the tension should not exceed the chain's limit, or it may break. When considering a chain mechanism, it's essential to consider the sprocket size. Avoid using a large ratio as it can lead to problems. A significant reduction in the chain mechanism results in fewer teeth on the small sprockets, making it more prone to break. It is recommended that the contact angle of the small sprocket should be larger than 120 degrees. Chain value refers to its size, with smaller chains providing smoother and quieter movement. It is advisable to opt for smaller chains. Another consideration is the number of the chains on the sprocket. Sometimes a single chain cannot withstand the tremendous torque. To address this, double chain or triple chain sprockets can be used instead. Multiple chain sprockets can drive more torque than a single chain setup. Remember that the force distributions may not be even, so it is necessary to evaluate the chains by multiplying the corresponding coefficients of the chain count. When the application is a threader, I must also consider another coefficients to overcome some impacts when threading. After evaluating all the chains-related factors, I calculated the chains in types 40, 50, and 60 for this application. However, even with the type 60 chain and triple chain sprockets, these chains barely handle the torque from the gearbox. Thus, this solution is unreliable. Since both attempts have failed, the only viable option is to return to coupling. The HRC coupling's original design is an economical and practical solution. The star-shaped rubber between the 2 flanges can withstand a certain degrees of misalignment in the axial direction. This type of coupling is capable of handling high torque applications. The taper's installation direction distinguishes 2 types of flanges. I got the type F, where the tapers are installed from the interior of the flanges. Make sure to choose taper inner diameter that fit with both the gearbox shaft and the threader box shaft, which are 25mm and 30mm. Use the set screws to fix the tapers onto the flanges. Once the tapers are installed, slide the flanges onto the corresponding shafts. Next, place the rubber on one side and push two flanges together to compress them. The coupling assembly is complete since the length of two flanges is the same as the instruction value. Let the length F in the table. The next video will talk about the frame build of this threader. If you enjoyed the video, please give a thumbs up and share the video. You may subscribe to the channel to keep up with more engineering projects or becoming a Patreon member. Thank you for watching and see you soon.